Okay, in this video, I'm going to talk about an exponential decay, and this is an example where y equals to a half raised to the x. Now, as I mentioned in the previous video, whether it's a growth or decay, the equation is a y equals to a times b to the x, where a is your y-intercept in this case. So you can see that any number raised to the 0 is just 1. In this case, when x is 0, we have a y-intercept, so we'll be left with a. So whether you have a growth or decay, the a value should be positive, or in other words, greater than 0. So this is both for a growth or decay. All right, so let's look at how we can graph the function y equals half raised to the x. Now in this case, what do you think your a value is? If you said 1, you are correct. Let's see what happens if we input a -3. So y equals to 1/2, and I input the value -3. What will happen to my function? So 1/2 raised to the -3 is actually the same as 2/1 raised to the +3, which is the same as 2 times 2 times 2, which is just 8. So 1/2 raised to the -3 is 8, and 1/2 raised to the -2 is just 2 squared, which is 4, and 1/2 raised to the -1 is the same as 2, and 1/2 raised to the 0, okay, in other words, 1/2 raised to the 0 is just 1. Any number raised to the 0 is 1. 1/2 raised to the 1 is 1/2. And 1/2 squared is 1/4. So if we input these points on the graph, let's see what our function is going to look like. At -3, which is right here for x, we have that y is 8. So at -3, the value is here 8. At -2, we go down to 4. And at -1, we have 2. And at 0, we have 1. And at 1, we have a half. And then we're going to go down to a quarter at 2. And then if we kept going, if you guessed what would be 1/2 raised to the third power, that would be just 1/8. And so I just keep getting closer and closer to 0 as I move to the right. So here where it says, what do you notice happens to y as x gets increasingly larger on the right? So we are approaching 0, but we will never reach 0. So as I mentioned in the previous video, that would mean we would have a horizontal asymptote at the line y equals 0. So let's draw that asymptote in. Here is the line y equals 0. You can see that the graph is approaching 0, but it will never reach 0. And if I drew the graph, then I have a curve that is going to the right and decreasing as I go to the right. So we call this a decay. So you can see if I place myself here, we always read a graph from left to right, I will be decreasing. So this is pretty much it for an exponential function that is a decay. Now notice the base here. The base for an exponential function that is a decay is always going to be a number less than 1 and greater than 0. Numbers that are between 0 and 1, what are they? Well, they're fractions such as a half, a third, a quarter, a fifth, or even a decimal, 0.1, 0.2. Basically, any number that is between 0 and 1 and where the a is positive is going to create a decay. Now let's look at the domain. The domain, just like the previous function we looked at, which was the growth, there are no restrictions on x. I could pretty much input any value for x here. If you look down this list, that means that we basically have all real numbers for our domain. The range, however, is restricted because we could see that the y will always be positive. Look at the y values. They are always positive And if you're looking at it closely, I'm always decreasing by a factor of 1/2. Well, that is because my base right here is 1/2. So that is called a decay factor. So the range here, we're going to say is y is greater than 0. You could see that the range will always be positive values. So this is my exponential function that is a decay.